discuss some, we'll start some kind of series. The series is basically on classical algebra, and we'll continue this series. And it is in the form of part 1, part 2, part 3. But you see the classical algebra. In classical algebra under Calcutta University or any other universities, you will see one of the famous book is Mapa. So we will just solve it according to schema exercise and the question paper which is given in different examination, and all the question paper, all the questions and solution are very important for BSc, IIT joint entrance, BMAT, WBSSC examination, WBSC examination, KVS, NVS, any other competitive examination. You will see the complex number is very common topic for all the examination. That's why the complex number is important. You will see or at least one or two questions from complex number, and it is basically classical algebra part. So here we can follow the book written by SK Mapa, and we will talking about the SK Mapa solution exercise wise. We need to know some theory, then we will continue some problem. So as per example, the complex number, our first recall is basically let Z be a complex number, Z be a complex number, then we can write Z in the form of Z equals to A plus IB, where A comma B both are real number. So now if we think about A, sometimes A is called the real part of Z, real Z, and B is called imaginary part of Z. So that means we can write Z equals to real Z plus I imaginary Z. So here real Z is basically what should be the value of real Z and imaginary Z. Now if we think about the next recall, the recall is basically conjugate of a complex number. So conjugate of a complex number, So now if we think about the conjugate of it is represented by Z bar, and it is basically A minus IB. You will think it graphically, say your point is Z equals to A plus IB is here. You can represent is a AB point. You just here consider this axis is basically real Z, x-axis, and along y-axis you just consider imaginary Z. So A minus IB is basically here. So just here the real Z is play the role of mirror, and it is one kind of so Z is here, so this will be A minus B. So that means this will be the Z bar. So Z bar is represented by this. Here important formula is if you just multiply Z bar, you will see it will be A square plus B square, and that is exactly related to the modulus Z. So the modulus Z whole square, because you know the modulus Z is basically, if you think about here Z A plus IB. So modulus Z basically distance between the points 0 and Z. So distance Z minus 0, that distance is represented by mod Z. So obviously this is important formula, very important. Z, this is basically Z bar. So it is very important. And here one thing is important, that next recall the Z bar. If Z bar equals to 1, then Z bar is called the multiplicative inverse. The multiplicative inverse of Z. So as for example, just the question paper which is given the KVS 2023, the Z equals to 2 plus 3i. So what should be the multiplicative inverse? What is the multiplicative inverse of Z? So here the question is, obviously the multiplicative inverse will be Z bar equals to 1 by Z. So 1 by 2 plus 3i. So that means 2 minus 3i by root under by 2 plus 3i multiple 2 minus 3i. So it will be 2 minus 3i by 13. 4 plus 9. So obviously 2 by 13 minus 3 by 39. This kind of question paper is given in Kvs 2003 PGT math examination, PGT math. So this is a very simple question. You will solve it within 30 seconds. And now we'll move to some properties, some important properties of complex number. And obviously we have learned it in HS level, complex number. As for example, the first property Z conjugate, and again you will take the conjugate, it will be Z, it will be Z, and next Z1 plus minus Z2, the whole conjugate, that will be Z1 conjugate plus Z2 conjugate. And next three, Z1 minus Z2, that conjugate, I have said it earlier, Z1 conjugate minus Z2 conjugate. And 4 is basically Z1 dot Z2 multiplication, the whole conjugate, Z1 conjugate dot Z2 conjugate. 5, Z1 by Z2 whole conjugate, obviously Z2 not equals to 0, Z1 conjugate by Z2 conjugate, where Z2 is non-zero complex number, non-zero complex number. Now, if we think about Z minus Z bar, it will be Z minus Z bar, so it will be 2 real Z, 2 real Z. So the formula for real Z is equals to Z minus Z bar by 2. So here one important question related to the modulus, and say mod of Z1, this property number 7, Z1 plus minus Z2, it is always less than equals to mod Z1 plus mod Z2. Okay, and next is mod of Z1 with respect to modulus into Z2, this is mod Z1 multiple mod Z2. And here one important, another important property is mod Z always greater than equals to real part of Z, and as well as mod Z is also greater than equals to imaginary part of Z. Now we'll move to, we can prove the property number 7 easily, but there is one important corollary. The corollary is like that, corollary, and that corollary is very, very important. You will see, you will prove it with the help of complex number properties. Mod Z1 minus mod Z2, that whole modulus less than equals to Z1 minus Z2. This is very, very important. You must recall it. You must recall it. This result is very, very important, and you will prove it very easily. How you will prove it? Just you think about the proof. You just consider mod Z1 equals to Z2 plus Z1 minus Z2, that modulus. It is obviously less than equals to mod of Z2 plus mod of Z1 minus Z2. Just you take is 1. Therefore, here you will see mod Z1 minus mod Z2, that quantity less than equals to mod Z1 minus Z2, their modulus. So just you will take it 2. Again you will start from Z2. Again it will be mod Z1 plus mod Z1 minus Z2. So obviously here mod Z2 minus mod Z1, this quantity less than equals to mod Z1 minus Z2. You will take it 3. So from 1 and 3, so from 1 and 3, or you can say from 2 and 3, we can prove that mod Z1 minus mod Z2, we can write that modulus less than equals to mod Z1 minus Z2, Z1 minus Z2. So this is very, very important, and this recall we can use to solve many types of problems in complex number. So complex number, here is one question. The question is given in KVS 2023 PGT, KVS 2023 PGT math. The question is, let Z1 and Z2 be two complex number, then which of the following is not true? Option A, Z1 plus Z2, that modulus less than equals to mod Z1 plus mod Z2. So well, statement is true. Here it is asked not true statement. So option B is given, mod Z1 minus Z2 less than equals to mod Z1 minus mod Z2. And option C, mod Z1 minus mod Z2, this modulus less than equals to mod Z1 minus Z2. And option D is mod Z1 plus Z2, that whole square, plus mod Z1 minus Z2, that quantity whole square, equals to 2 into mod Z1 square plus mod Z2 square. This is basically the parallelogram law. So this statement is true. This is a true statement. This is also a true statement. This is also true, but the statement is basically false. So we need not true statement. So obviously option B is correct. So you can verify by using different kind of examples. Say, as for example, you will take, say, 2i, z1 equals to 2i and z2 equals to I. So 2i minus I, that modulus is basically, or you take z1 equals to I and z2 equals to 2i. So obviously this will be plus I minus I, so minus I modulus, it will be 1. But what about mod of z1, that is I, this is equals to I. And mod of z2, this is basically root under 4, so this will be 2. So obviously here you will see 1 less than equals to 1 minus of 2, that means minus 1. This is a huge contradiction. So obviously the option B is false. That question is exactly given in Kvs PGT Mathematics examination. These are very important questions, and you can prove the question very easily. The option D, that proof you need to do it. This is very, very important, and this is called the parallelogram law. So here the proof is basically mod z1 plus z2, that modulus square you just use. This is very, very important formula. Mod z square equals to z into z bar. So that means z1 plus z2 and z1 plus z2 whole bar. So z1 plus z2 multiple z1 bar plus z2 bar. You just apply the distributive law, and you will apply this formula again. You will get this will be z1 square plus z1 z2 bar plus z1 bar z2 plus mod z2 whole square. In similar way, for z1 minus z2 the square, that means it will be mod z1 square minus z1 z2 bar minus z1 bar z2 plus z2 square. In similar way, you can solve this. So from 1 and 2, you just add this expression 1 and 2. What will be the result? z1 plus z2 the whole square plus mod z1 minus z2 the whole square. It will be, here you just see this minus quantity and plus quantity, that is cut, and this is also cut. So obviously it is 2 z1 mod z1 square plus 2 mod z2 square. So 2 into mod z1 square plus mod z2 square. So obviously the statement is true. Here it is asked not true statement. So obviously option B is the not true, and all the option is all other statement is basically true. So there is one important question in complex analysis that is very, very important in BSc and obviously IIT and any other examination, NBS, KBS, obviously WBSSC. And the question is basically what should be the greatest value and least value mod z. So the question pattern is greatest and least value of modulus of z. So in that case, the question is given like, let z be a complex number, satisfying the condition, mod of z minus 3 by z, this is equals to 2. You have given that kind of information, and from that you will find the maximum value of mod z. The maximum value of mod z and the minimum value of mod z. Minimum value of mod z. So I just written in a question pattern, but they can ask in the MCQ type the maximum value of mod z and minimum value. Then find maximum value. So maximum value of mod z, for we just apply the trick. Here the trick is like that. We have already used this thing, the mod z1 minus mod z2, that modulus less than equals to mod z1 minus z2. Okay. So this trick is very important. You need to know this formula for all z1, z2 belongs to the complex number. So if you know this formula, you just use this formula here. We need to know about the mod z. So we can use mod of z minus 3 by z. Just like you take z1 as z and z2 as 3 by z, and you take the modulus. So this should be z minus 3 by z. Just you see, we can use here because the condition is given. So here you will write this is basically 2, and this will be, so just you think about mod z equals to r. Say this is the modulus, the distance from the origin. If you take it r, so obviously r minus 3 by r, that modulus less than equals to 2. And here you will see the inequality. The inequality is basically minus 2r less than equals to r square minus 3 less than equals to 2r. Here r is basically mod z, so obviously we can consider r is greater than 0 or greater than equal 0. R is distant, so it always non-negative. So now we'll apply the inequality. We'll get two equations. One equation is either r square minus 2r minus 3, that is less than equals to 0, and other portion is another equation is r square plus 2r minus 3, that is greater than equals to 0. You just simplify these cases. So r minus 3 into r plus 1, this is less than equals to 0, and r plus 3 and r minus 1, this is greater than equals to 0. So this implies 0 less than r less equals to 3, as r is greater than 0 and r greater than equals to 1, since r greater than 0. So obviously if we combine these two, because if we think about the real line, this is 0, this is 1, this is 3. So in one case it is saying that belongs to this, in the other case it is saying r greater than equals to 1. So this is a common portion. So obviously 1 less equals to r less equals to 3. So here we can conclude the greatest value of r is mod z. Mod z is 3, and the least value of r is 1, because since mod z equals to r, so we can say the greatest value and the least value. You have given maybe similar kind of problem. So you need to very careful about all these problems. The question, just your assignment, the similar kind of problem. Say this is your homework or assignment. The z is a complex number such that z minus 10 by z, this is equals to 3. So you need to find out in similar way, find out the value of mod z, not the value of the maximum and minimum value of mod z. So I hope you will do it, because you will do the similar strategy, you will follow the similar strategy and you can solve it. This is quite simple. Now we'll move to the another problem. This is related to the argument. So if you have given a question like find argument of z, where z equals to 1 plus I tan 3 pi by 5. So in that case, this question is very important. This question is given many more examination. So just we need to find out the polar representation. The polar representation of just you consider z equals to r cos theta plus I sin theta. Just compare with this. So if we compare, so the value we can write 1 plus I tan 3 pi by 5. This is equals to r cos theta plus I sin theta. I sin theta. So here we can write the r cos theta equals to 1 and r sin theta equals to tan 3 pi by 5. So we need to find out the modulus and as well as the amplitude. So if we think about first modulus, so here r square will be 1 plus tan square 3 pi by 5, 1 plus tan square theta, that means sec square theta. So sec square 3 pi by 5. And this gives r equals to minus sec 3 pi by 5. Actually it will be plus minus, but plus is not here. Now we take the minus sign. Why minus sign? Because minus sec 3 pi by 5, this is less than 0, this is negative, and before that we have a negative sign, so negative and negative it will be positive, because the r is basically the modulus, and the modulus is always, it will be greater than equal to 0. So that's why r is not plus sec 3 pi by 5, r is basically minus sec 3 pi by 5. So this determines here we can write cos theta equals to minus cos 3 by 5 and sin theta, this is equals to minus sin 3 pi by 5. So that means here theta equals to pi plus 3 pi by 5, where theta equals to like this, currently we know it will be the argument, the principal argument always belongs to minus pi less than theta less equals to pi. So this is the range of the principal argument of z. So obviously since here theta is greater than pi, so theta is here, the theta is greater than pi, theta is pi plus 3 pi by 5. So it actually does not satisfy the range of the principal argument. So it does not give the principal argument basically. So the principal argument, I am right here. So principal argument arg equals z equals to, it will be theta minus 2 pi. So what is theta? Theta is basically pi plus 3 pi by 5 minus 2 pi. So obviously the answer will be minus 2 pi by 5. So minus 2 pi by 5. So here answer is minus 2 pi by 5 is basically the principal argument of this complex number. So this question is very straightforward and it is very, very important for any kind of PSC level examination, KBS, NBS and SSC, as well as the BSc examination. So this is very, very important and you must recall this kind of result. It will help you to strike out within a very small time of interval. You can do it. So next we will move to the another important recall. The recall is basically related to de Moivre's theorem. So the recall is basically de Moivre's theorem. De Moivre's theorem. In de Moivre's theorem is basically when n is integer, either positive or negative. So n is integer, either it belongs to the z plus positive integer or z minus, and theta is a real number and theta belongs to real number, then we can write cos theta plus I sin theta whole to the power n. This will be cos n theta plus I sin n theta. But the thing is, if n is fraction, either positive or negative fraction, so that means when n belongs to q plus set of all positive rational and q minus negative rational, so and theta is real number, then we can't write equality symbol, we write cos n theta plus I sin n theta. This quantity is basically one of the value of cos theta plus I sin theta whole to the power n. So this formula, or you can say the theorem, de Moivre's theorem, is very, very important to solve the nth root of a complex number. say how to find out the nth root of a complex number. Uh, so if the recall is basically here, this is very important. The Z is a non-zero complex number and n is positive integer. Complex number, n is positive integer, n belongs to the natural number. Then there are n distinct values of z to the power 1 by n. So this is very important. You will see the proof in different books, especially in Mapa. You will see the proof, and this is a very important theorem. Here, one important application related to the de Moivre's theorem, very famous application. This is basically z to the power 1. So this is here you can calculate the z. Z is basically 1 to the power 1 by n. But how many? This is the equation or in polynomial in z, and the degree is basically n. So obviously it has a n root. According to the fundamental theorem of classical algebra, every algebraic equation must have a root. It is real or complex. So obviously z to the power n, according to the fundamental theorem, it has a n root, either real or complex. So we have application. We need to find out the nth root of unity. This is called the nth root of unity by nth root of 1. So we need to find out the nth root of 1. So just we apply the de Moivre's theorem. So z to the power n equals to 1. We can write it cos 0 plus I sin 0, and it has nth root. So z equals to, we can write cos 0 plus 2k pi plus I sin 0 plus 2k pi. Now the question is, what is the range of k? K equals to 0, 1, 2 up to n minus 1. This is z to the power n. So obviously it has nth root by the fundamental theorem. N number of roots is there, either real or complex. So then we apply, this will be cos 2k pi plus I sin 2k pi whole to the power 1 by n. So where you need to write in each steps 0, 1, 2 up to n minus 1. So the value of z will be the cos 2k pi by n plus I sin 2k pi by n, where k equals to 0, 1, 2 up to n minus 1. So we can write it cos k 2 pi by n plus I sin 2 pi by n whole to the power k, where k equals to 0, 1, 2 up to n minus 1. If we apply the Euler's theorem, it will be e to the power I 2k pi by n, 2 pi by n whole to the power k. And if we take it as alpha, so the roots of z to the power n equals to 1, the complete list of roots. You can think about the complete list of roots of z to the power n minus 1. That complete roots, just you consider e to the power 2 pi by ni. This is basically alpha, so it will be 1 alpha square dot alpha to the power n minus n. So here the main thing is, if n equals to odd number, odd integer, so odd positive integer, the number of real roots of z to the power n equals to 1 is 1, and if n is even positive integer, a number of real roots of z to the power n equals to 1 is 2, and they are plus minus 1, and here real root is 1, and this will be, this is 1. 1 is the real root. Here 1 and minus 1 is this, so number of real root is basically 2. So we can find out the other roots are basically complex, and it depends on how many real root edges. It depends on n is positive, odd integer or even integer. So as for example, if we think about the cube root of 1, so cube root of 1, as for example, cube root of 1. So in that case, the root is 1 omega and omega square. Just you see, x cube or z cube equals to 1, z cube equals to 1 here, n equals to odd positive integer, the number of real roots is 1 and omega square, they are the complex root, and where omega is basically e to the power I 2 pi by 3, so that means cos 2 pi by 3 plus I sine 2 pi by 3 according to our formula. How you will find out the nth root of unity? You will see 1 omega square cube root of unity. Similarly, we can find the cube root of minus 1. This is example 1. Example 2, cube root of minus 1. So cube root of minus 1, this is minus 1 minus omega and minus omega square, where omega equals to e to the power I 2 pi by 3. In similar way, you can find out. Now we'll move to the fourth root of 1. So that means z to the power 4 equals to 1. Here z cube equals to minus 1. So this will be 1 minus 1 minus I, and iota equals to root under minus 1. So the question is very, very important. This question is important for any other examination. It may be BSc or B Math or Kvs PGT. Whatever the question is, the sum of the 99th powers of the root of the equation, of the roots of the equation x to the power 7 minus 1 equals to 0 is, we should be say option 1 is 0, option B is 1, option C is 7, and option D is 99. Which option will be correct? The sum of the 99 power. This is very, very important. You can recall it. So we can solve it in different way, but here we just solve it very classically and with respect to the knowledge base. So the root of x to the power 7 minus 1. You need to calculate first the root of x to the power 7 minus 1 equals to 0. So when the root is, you will find out the root, then you will sum all the 99 power of each root, and then you will calculate the value. So if we think about x to the power 7 minus 1 equals to 0, so the root is basically 1 alpha square dot alpha to the power 6. What is alpha? Where alpha is basically e to the power I 2 pi by 7. So that means cos 2 pi by 7 plus I sine 2 pi by 7. So here the interesting fact is, if we think about the roots, so this is a complete list of roots. So we'll take the 99 power of each roots. So 1 to the power 99 plus alpha to the power 99 plus alpha squared to the power 99 plus dot alpha to the power 6 to the power 9. So this is basically sum of the 99 power of each roots, and you can write 1 plus alpha to the power 99 plus alpha to the power 99 whole square plus dot alpha to the power 99 whole to the power 6. So just to think about the geometry progression, 1 plus r square plus dot r to the power 6. So that will be 1 minus r to the power 7 by 1 minus r. So we'll already learn it in geometric progression. So this will be 1 minus alpha to the power 99 whole to the power 7 by 1 minus alpha to the power 99. So just to think about alpha to the power, alpha is the root of the equation. Alpha is a root of x to the power 7 minus 1 equals to 0. So it satisfies the equation. So alpha to the power 7 equals to 1. So here we can write alpha to the power 7 whole to the power 99 equals to 1. That means we can write alpha to the power 99 whole to the power 7 is also 1. So this is basically 1 minus 1 by 1 minus alpha to the power 99. So the value is basically 0. So the correct option is option A, and all other options are basically false. So this is one of the good question, and you can recall this question, and it will help you to strike out the option within 5 seconds. Now we'll move to the another important question. The question is basically the product of all values of I1 plus I whole to the power. So the product, find the product of all the values of 1 plus I whole to the power 4 by 5. How you will solve? There may be the option A is 1, option B is 4, option C is minus 4, or option D is 8I, like that. So what should be the product? So just you need to think about first 1 plus I whole to the power 4 by 5, and we can write 1 plus I as root 2 cos pi by 4 in the polar representation of 1 plus I. So polar representation of 1 plus I sine pi by 4, and the power is basically as usual here it is given 4 by 5. So we can apply the de Moivre's theorem, and we can write it for cos pi plus I sine pi to the power 1 by 5, whole to the power 1 by 5. Here is just to use the formula. So there are 5 distinct values. And what are the 5 distinct values? Because we just think of the fifth root of number. So as for example, say z to the power n equals to some alpha. So obviously z equals to alpha to the power 1 by n, and obviously the root of z to the power n equals to alpha must be 5. So they are 5 distinct values, or there are 5 distinct values. Now the question is, what are the 5 distinct values? The 5 distinct values will be fifth root of 4 cos, we just apply 2k pi plus pi by 5 plus I sine 2k pi plus pi by 5. So where what is the k? K is equals to 0, 1, 2 up to 5 minus 1. So that means 4. So now you take the product. So the product of all these values, the product of all the values, this product will be, so fifth root of 4 I will product is 5 times. So it will be just 4, and the next is cos pi by 5 plus I sine pi by 5 whole to the power 5 into cos 2 pi by 5 plus I sine 2 pi by 5 whole to the power 0 plus 1 plus 2 plus 3 plus 4. Why I have written in this pattern? Because if you think about the expression, so this expression equals to the 4 to the power 1 by 5. You can write it cos pi by 5 plus I sine pi by 5 multiple cos 2k pi. So cos 2 pi by 5 plus I sine 2 pi by 5 whole to the power k, where k equals to 0, 1, 2 up to 4. Now you take the product, you will get this value. So you just simplify these values and you will get it. The value will be minus 4. So minus 4 will be the correct option, and all the options are basically false. Here one interesting question is also, that question will be given in any kind of examination that I have mentioned already. What should be the value of nth root of I plus again nth root of minus I? What should be the sum? So this is one important question. Or the question is like that: prove that nth root of I plus nth root of minus I, that value is 2 cos pi by 2n. What is n? N is a positive integer, and obviously this positive integer greater than 1. Natural number, but it starts from 2, 3, 4, 5 like that. So how you will prove? So obviously here from this statement you will see that value will be cos 2 pi by 2n. How? Because I equals to, as hints, or you can think about a short proof. So we can write iota as cos pi by 2 plus I sine pi by 2, and minus iota as cos minus pi by 2 plus I sine minus pi by 2. So in that way you can express. So obviously here nth root of I, we apply the de Moivre's theorem. So cos pi by 2n plus I sine pi by 2n, and nth root of minus I, that will be cos minus n pi by 2 plus I sine minus n pi by 2. sorry, it will be 2n, and it will be 2n. So now we just add this to number. So nth root of I plus nth root of minus I. So it will be simply cos 2 cos pi by 2n. Because you just apply cos of minus theta equals to cos theta, because cos is even function and sine of minus theta equals to minus sine theta. And you just add equation 1 and equation 2 and you will get this value. So this value you can recall as a formula, nth root of I plus nth root of minus I equals to 2 cos pi by 2n. So if you ask this kind of question, the value of root I plus root under minus I is, say, option A is 2, option B is root 2, option C is 2 root 2, and option D is 1 by root 2. What should be the value? Just we apply the formula. According to the formula that we have learned previously, I root under minus I, this will be cos 2 2 cos, we just see the formula, pi by 2n, n equals to 2, so 2 cos pi by 4. So 2 into 1 by root 2, and the value will be root 2. So root 2 is the value, and you can solve it easily by using this formula. So similarly, the assignment is basically homework or assignment. Cube root of I, cube root of minus I. What is the value of this? You have given the assignment, say 2023 root I plus 2023, that fifth root of minus I. So what should be the value? So they can ask any kind of question like this. So you need to solve it rigorously. You can do it easily, in fact. So as for example, that is another question like that, how to solve the equation, say x to the power 6 plus x to the power 5 plus x to the power 4 plus x cube plus x square plus x plus 1 equals to 0. So how to solve it? How to solve the equation? So the equation has degree. If you think about the degree of the equation, so degree of, say, this is a polynomial px, say here 6. So that means by using fundamental theorem, it has a 6 roots, either real or complex So now we need to find out the roots of this equation. How we will solve it? Just you will multiply this equation by x minus 1 on the both side, x to the power 6 plus x to the power 5 plus x to the power 4 x cube plus x square plus x plus 1. So multiply both sides, it will be x to the power 7 minus 1 equals to 0. So the root is basically x equals to cos 2 pi by 7 plus I sine 2 pi by 7 iota to the power k. What is k? Where k equals to 0, 1, 2 up to 7 minus 1. That means 6. Okay, so these are the basically roots of the equation. X to the power 7 minus 1 equals to 0. So we can write it, the root of x to the power 7 minus 1 equals to 0. The complete list of root 1 alpha square dot alpha to the power 6. What is alpha? Alpha equals to e to the power iota 2 pi by 7. This is the root of x to the, but here the question is root of this. So just we have multiplied x minus 1, so 1 is just extra root. So obviously the root of x to the power 6 plus x to the power 5, it will be alpha square dot alpha to the power 6. Okay, what is alpha? Where alpha equals to e to the power I 2 pi by 7. Just you apply Euler's theorem, it will be cos 2 pi by 7 plus I sine 2 pi by 7. So these are the 6 roots of this equation. So similarly, we can solve the equation in the form. This is x to the power n minus 1 plus x to the power n minus 2 plus dot x to the power x square plus x plus 1. Like this, we can solve the equation by just multiplying x minus 1 on both sides, and it has a n minus 1 root alpha square dot alpha to the power n minus 1. What is alpha? Where alpha equals to e to the power I 2 pi by n. So iota means root under minus 1. So you can find out easily the root of the equation. So thank you so much. I hope you will practice much more, and you will solve all the problem like what is exactly